When using the classical or critical value method to determine whether to reject or not reject the null hypothesis, what we're going to do is draw the normal distribution. So that's my first step. So I have my normal distribution, and I'm going to find my rejection region, and that's based on the critical value. So in this particular problem, 34, the critical value is 1.64. So I'm going to locate that on my normal distribution, and I start with finding the center, and that's at 0. And then I'll mark 1, 2, 3 standard deviations to the right, and that's +1, +2, and +3, and then 1, 2, 3 standard deviations to the left, and that's -1, -2, and -3. So my rejection region is going to be defined by this critical value, 1.64. So I'm going to locate that critical value. So 1.64, that's going to be between 1 and 2. So I'm going to say, okay, that's off. It's about there. And so my rejection region is anything into the tail. So we're going away from the center. Because this is a right tail test, we're only going into the right tail. So we've got 1.64 as our cutoff here, and anything to the right of that is going to be in the rejection region. Anything to the left of it, we would not reject. So the test statistic is 2.04, and that test statistic is to the right of our critical value. So you can see that on your diagram right there, 2.04. That is to the right. It is in the rejection region, and so we would reject the null hypothesis. Okay. Now let's take a look at 35. Here we have a left tail test. So I'm going to start by drawing my distribution. Find the center is 0. 3 standard deviations to the right, 1, 2, 3. 3 to the left, 1, 2, 3, negative. And here my critical value is negative 2.33. So I'm going to put that on my distribution here between 2 and 3. And rejection area is to the left of negative 2.33. And so now I need to find where is the test statistic negative 2.21. And that would be to the right of our critical value. So kind of squeezing it in there. Negative 2.21. And so I'm really not trying to be super precise with exactly where is negative 2.33 and negative 2.21. I just need to know left and right. So is negative 2.21 in the rejection region? No, it is not. So do not reject the null hypothesis. Because what we're saying here is that our test statistic, this is what comes from our sample information, is it falling far enough away from the center to say that it's different from whatever the null hypothesis says? And so we're saying here it's not far enough. It's not into that rejection region where we say, no, that's crazy that it would fall that far out there. There has to be a cutoff, and so this is close to the cutoff, but it's not beyond the cutoff. So that's what our question is there. Okay, in 36, we have a two-tail test. The critical values are plus or minus 2.05. So now with a two-tail test, all right, again, I've got my center is 0, 1, 2, 3, 2, 3. And critical values are at plus or minus 2.05. In a two-tailed test, we're going to have two critical values. So we have positive 2.05, and we have rejection region to the right of that value, to the right of the positive value. And then we're going to have rejection area or rejection region to the left of the negative 2.05. And where is our test statistic? It's at 2.67. So that is in the rejection region. And so we're going to reject the null hypothesis. So those three show you how to use the critical value method to determine whether to reject or not reject the null hypothesis. Now let's take a look at 37. Here we're using the p-value method. And this is a lot easier because I can draw the distribution, but I really don't have to. I really just need to compare the p-value and alpha. So in this case, we have p equals 0.37, alpha equals 0.01, and my question is just which is larger, p or alpha? In this case, p is larger. And what this is the probability of falling beyond the test statistic. So what we're saying here is that if I looked at this distribution, and I don't know whether this is a left tail test, a right tail test, a two tail test, it doesn't really matter. So I'm going to assume it's a right tail test. Our critical value is going to be, well, I don't know, but we've got alpha is 0.01. That's our significant, level of significance. So alpha is 0.01, and we're going to put an area of 0.01 here. And would this area, 0.37, take up more room than the 0.01? Yes, it would. So 0.37 is maybe going to take up this much space because they both go into the tail. So in that case, my test statistic would not be falling in the critical region. So I really just need to know which is bigger. If p is larger, then I do not reject the null hypothesis. And if alpha is larger, then I do reject the null hypothesis. If they happen to be equal, we would go with do not reject. And now let's take a look at 38. In this case, we have a p-value, which is 0.03. Alpha is 0.05. And since alpha is larger than p, this means we're going to reject the null hypothesis. So that's how you do those problems.